Hello everyone, welcome to the assignment lecture of week 11. In the week 11 summary, we have discussed about the advancement of the field of climatic streams in when we are including different types of non-linear modeling setup, for example machine learning, AI and all, or let us say if you can integrate the cloud based the data platform where all the simulations, all the analysis can be done in not in a local machine, but can be done in a basically a cloud based server or cloud based data storage platforms. On then we have also discussed about the role of the big data set in the climatic stream studies, because if you are talking about climate change projections, or let us say high resolution data set which we are covering for different spatial location on the earth. So, that requires lots of data set observational, and that is basically we can consider as a big data format, where we have a volume of data that is basically changing very fast, and that has variety of the variables as well. So, in that particular context, we have discussed about the assignment, which is basically we discuss about we have to explore a cloud based platform, for example Google Earth Engine, and how we can use that particular platform in climatic stream study to look at different types of data set, and that can be you can use that data set for different types of climatic stream analysis. How? Because we know that there are so many data sets which are available in the Google Earth Engine, which are coming from directly from the satellite. So, how the satellite information is relevant? We have talked about multiple times early warning system or zonation of the area where climatic streams are more frequent, right? How do we do that? Suppose we are talking about early warning system, or let us say we are talking about zonation. So, for that basically we need a continuous record of the data set for multiple points, spatial locations as well. How do we do that? The satellite is a very good option because it can cover a large area proportion, and that can give you the information about the reflections and how the earth surface are changing because of the extreme conditions. Let us say we talk about flood. So, satellite data, for example synthetic aperture radar or different types of Landsat or MODIS data set can be utilized to understand, let us say, how much area are going to be inundated or has been inundated in the historical period. That information is very critical, because when we have that information, we can be able to predict the probability of occurrences of different water pixels or water areas in different region. That will helpful to understand, let us say, which area has the higher probability of the water occurrences if a certain magnitude of rainfall will exceed. And then based on that information we would be able to provide some sort of zonation of that area. We can provide different zones, zone 1, zone 2, zone 3, zone 4, like that, where we can strictly prohibit any particular type of activity in a one particular zone, zone 1 which is very close to the river channel, and then zone 5 or zone 4 we will say that okay, moderate scale of the construction activity will be allowed under some sort of precautionary measures like that. So, this is kind of a one conditions for flood analysis. We can talk about there are multiple satellite which are also revolving around earth and are continuously covering data set based on rainfall, evapotranspiration, or let us say multiple different hydrological properties as well. Those hydrological properties are very critical, because that would help us to understand, let us say, how much amount of water we are losing every second or every year or every month, like that. When we have that information, that is very useful for predicting in which part of the year or which part of the region or which part of the different types of spatial location, like that, where we have higher frequency of the drought event, right. what factors are basically are the major driver of the drought in that particular region. So, when we have this kind of information, we would be able to spatially map these drought locations, and we can highlight those regions which are hotspots, and we can provide some sort of extra measures. So, we can also look at, let us say, whether we have surface water data is available or not, how much distance is from those locations which are frequently affected by the drought events like that. So, these kind of the information, when we are trying to figure it out or we have to solve it, there the cloud based programs plays a very critical role. So, here we will discuss about first one of the most widely used cloud based program, that is called Google Earth Engine. Okay. So, this is a platform, if you wanted to access, this is how basically you can open this particular program, that is earthengine.google.com. When you enter this particular HTTP link, you will be able to open this particular website. So, if you look at here, it says that a planetary scale platform for earth science data analysis, which means the data which is provided in this particular platform is planetary scale, it's global scale, and therefore, you will be able to see multiple types of features, land surface feature or different types of parameters over the globe, and you can do not specific to your country or your region or your locations, you can do any analysis to any particular type, or maybe you can compare, let us say, your particular region with your similar hydroclimatic regions around the globe, and then you can look into it key whether is there any role of human activities are more pronounced here, or the climate change is more effective or more extreme in that particular regions like that. So, that kind of the analysis you can do using when we have the planetary scale platform for earth science data analysis. So, what is this is all about basically? So, if you look at this particular figure, it basically tells that there are satellite imageries and different types of data set which are available in this particular platform. You have to write your algorithm, which means you have to write a simple code, extraction of the imagery from a certain satellite data, calculate some sort of drought index from that imagery, a water availability index, let us say, and then based on that we can replicate that index calculation for monthly scale for that particular region, and based on that we will be able to say that okay, how many months in the previous historical period where the water has been significantly dropped or very less amount of water below that particular threshold. So, that is a very simple algorithm which you can do, and then we can identify the years, and then you can relate with years with some sort of governing factors, whether you have more hot extreme that particular year, or you have some sort of ENSO event or some sort of local meteorological effect. So many things you can, or maybe you can think about correlating with the NDVI, normalized difference vegetation index data set, and then you can get an idea about how the forest cover or the loss of the forest covers are actually contributing to changes in the water surface availability or hot extremes or drought condition in certain regions like that. So, that is a part of algorithm based on our hypothesis. We can model it, we can basically write in a code format, and then based on that satellite imagery and your code, you can club it together, and then you will be able to get a real world applications where you would be able to you be able to tell about how you can implement your satellite imagery with your algorithm, and then you can solve for the real world examples. So, there are so many different applications which has been already made, and that can be used to provide a very in depth analysis of how you can use this Google Earth Engine for your analysis. So, I will give you a little bit more about the code editor of this particular not this one, I have to go overview. Okay. So, here when you click it here, this code editor, it will basically redirect it to you one particular link where you have to select make an account in this particular Google Earth Engine platform, and then you can relate with your one of your, let's say, Gmail account or your institute account, and then you can make it one particular account for your Google Earth Engine platform. Once you have already set up the program that your login IDs, you will be able to see something similar like this code editor, where you have multiple types of boxes and multiple types of area, different types of segments here. So, for example, if you look at here, it is a kind of map layer, or here you can see the maps of different countries. So, suppose you are working with some area in India, so then you will be able to zoom it here in Indian region, and you can look at your region with your zoom geometry tools like that. And here you can also change the layers. So, by default you are showing you are seeing like this. Maybe you can change something different layers which will give you information about what you are working with. Let us say you have NDVI, process the NDVI data, you can also show the NDVI within this particular platform as well. Here this is basically called there are three things here. One is called the script manager, which is basically arrange your script and all. Then there is a assets. Assets is basically a kind of the data set which you are uploading in the form of save file or some sort of boundaries or points or locations like that. That is basically assets. For example, if you are working in analyzing the rainfall extremes in the Delhi, you need to have a Delhi boundaries, right, New Delhi's boundaries. So, if you have New Delhi's boundaries, you can basically use that shape file, you can enter it in assets, and you can start extracting the data for New Delhi, and then you can look into it how the rainfall or temperature has been changed over the past 40-50 years like that. Then there is basically a docs, where we have API documentations, where you have all the helps, all the things which are relevant to Google Earth Engine are listed here. You can go to that particular docs and read about a particular command, or let us say how you can use different types of commands in the Google Earth Engines like that. In the center of this particular code editor, you have some sort of space where you can write. Here you can write about the code, which basically you can code different types of instructions, set of instructions you can add here, and that will execute. You have to run the code from this particular button, and you will see some sort of results here, which will give you about what is the total property of the data set which you are exploring, and if there is any error in the data set or this particular code, you can also debug that error from this particular help functions, or basically this right corner, this box here. Here also you have console and task here, which can give you information about your output data set, your overall graphs and all. So, those all the informations are provided here. So, for example, this is one graph which is basically calculated from the Google Earth Engine. The night light trends of a certain region, probably Eastern Europe, and then basically here you can see that there is a brightness over time is decreasing sort of in this particular regions. So, based on that information, you can also look into it how much area of a certain region has been urbanized or has been changed because of the urbanization, and because of that probably you have more effect of urban flooding or urban heat extremes in that particular regions like that. So, this is the information which is giving you how the code editor is looking, how the code editor is working in the Earth Engine code platform, and how you can use it for different types of analysis and all. So, you can go ahead with the platform, code editor, make an account, and then you can start looking at the code editor in your laptop or computer. Then there is another important things of Google Earth Engine is because it's a cloud based. So, whatever you are writing here, it will execute in the cloud platform. It will store your script or your program or your instruction in a file in a cloud, and you can access it anywhere. You can access it in your laptop, you can go to your office or let us say your college, and then you can use it that script, the saved script from their computer by logging your credentials to the Google Earth Engine. So, you do not have to carry those scripts in a one particular laptop or hard drive or hard disk or pen drive like that. Then this another feature is in the Google Earth Engine is the data set. Okay, if you click the data set, you will redirect to this particular redirect to this particular web page. Here you can see that there are lots of data sets are available. So, here you can see that there is a lots of category of the data sets are available. For example, you have surface temperature data, or maybe you have broader category of the climate data. So, you have then let us say atmospheric data set or weather related data set, then you have Landsat data, you have Sentinel data, MODIS, high resolution imageries, land cover data, terrain data, that is a digital elevation model data, and there are so many other types of agricultural data or other geophysical data set like that. So, lots of data sets are stored here. Let us say we are interested in the climate data, and then we have clicked this explore climate data tab. Now, you can see that there are lots of climate related data sets has been is currently showing in the screen right now, and this is a part of the Google Earth Engine cloud based data set storage. So, for example, if you look at here, you have some sort of radiation data set where we have climate forecast system reanalysis data set, we have climate forecast 2 and 6 hourly products data set, we have CHIPS daily climate hazard center infrared precipitation with station data version 2 final, and it is a pentad version where we have 5 days average like that. So, let us say if you open this particular data set, so if you look at here, this is basically the data set is available with the station data. This is basically what type of the data. If you look at here description, so this is CHIPS is a 30 plus year quasi global rainfall data set, which basically incorporated a 0.05 degree resolution satellite imagery with in situ station data to create gridded rainfall time series for trend analysis and seasonal drought monitoring. So, in this type of data you have the hybrid data set where we have global rainfall data set which are covered by the satellite imagery with you have the in situ rainfall data set, and you are combining it together, and based on that combination you would be able to create some sort of a global data set for rainfall measurement, where we have higher density of the station network, where we have the lower density of the station, that does not matter, because you have already validated with the higher density stations with your satellite data set. And then of course, when we have lower station density, there will be we have a lower higher uncertainty in the rainfall measurement. But you can use this data set for different types of analysis. If you go to the bands version, you can see there is a one variable which is precipitation is present, and which is the unit is mm per day, and that the minimum value is 0 and sometimes the maximum value goes up to 1444 mm per day. That is the precipitation data set is available in CHIPS, and we can use it. So, how do we use? We can call this data from this particular Earth Engine snippet. You basically use some sort of assets of say file, a boundary of a location. You can add that boundary, and then you can do some sort of multiple analysis. Let us say you can extract the data for temporal time period, daily data, average spatial data for daily values, or maybe you can think about making some sort of spatial data, where for each grid you have spatial value of the temporal data set, and that you can plot it, and you can make some sort of beautiful spatial plot how spatially your data is varying in that particular regions like that. So, that is basically one type of the data set which gives you information about rainfall. That is very important data, because if you have this kind of data set, you would be able to calculate how the rainfall extreme has changed in 30 years based on some sort of frequency analysis, or let us say you can use some sort of threshold based analysis, or maybe you can think about making some sort of drought analysis, SPI, SPEI, like that. That kind of the analysis can be done and can analyze how the drought patterns are changing in different parts of the world, and how we can look into it a local or regional hotspots, and what is the reason behind it if a large area is basically affected by a certain drought events like that. Then you can look at multiple other type of data set. For example, if I search it Sentinel yes. So, if you look at here, there is a Sentinel data set where, so it is under climate, so that is why we are not able to get. So, if you look at here imagery, this is Sentinel data. So, if you look at here lots of Sentinel-1 and Sentinel-2, this is a C-band synthetic aperture radar, and this is Sentinel-2, which is the multispectral instrument data set are available, and that can be used to get an idea about how the informations has been changed, or land surface properties has been changed over the past 10 years or like that. So, for example, this data set is available from 2014 to 2025. So, we have multiple bands which are available, HH, HV, VV or VH. This is a kind of the polarization. You can read about this polarization in the synthetic aperture radar, and how we can use different sets of polarization image to get a more detailed overview of a particular type of object. What is the advantage of these radar data is, when we have, let us say, monsoon period, we have the higher cloud cover during the monsoon, and therefore, most of the optical based satellite system, which is Landsat and all, are fails to capture the data during the monsoon, because there is a large scatter they record because of the cloud cover and all. But the advantage of the radar is it can penetrate inside the cloud cover, and therefore, you would be able to see lots of new features or more features compared to the Landsat, and you can also use that Sentinel data set for, let us say, flood monitoring, because most of the time when floods occurs, we have a higher rainfall amount, higher rainfall or cloudy days or like that, and therefore, if you have radar data set, you have a more detailed analysis of the how the extent is changing, how the river has been behaving during a particular flood period of time, or how the different types parts of the area are affected like that. So, this is a Sentinel data is very useful in that sense. Okay. Now, there is another type of data set. If you go to again the climate data, I am giving you a very broad overview about different types of data set. Now, you can go to one by one these data set, and you can start making some small script, and you can analyze extract the data set, and you can analyze that how the temporal trends are changing or spatial patterns are behaving like that. There is another data, let us say ERA 5, which is very common data, ERA 5 land daily aggregate ECMWF climatary analysis. So, if you open this data set, it is a sort of reanalysis data, which is also available in the Google Earth Engine. Now, you can use this data set, it is available from 1950 to 2025, and there are so many bands, right. If you look at here, there are so many temperature data set, okay. You have snow cover, snow density, snow depth, we have snowfall, then you have forecast albedo and all. Then you have basically latent heat flux, surface net surface radiations, lots of data set you have in the this particular variable. You can use this variable and you can look into it how the response of the climate system has been changed because of certain processes, or let us say increasing activity of humans in a certain region. Let us say if you have a basin or area where you have observed there is a significant reduction of the forest cover, how this forest cover has been affected the drought frequency of that region. You can also check or analyze using this kind of the data set. You can basically use latent heat flux, you can use the Bowen ratio, you can use the sensible heat, you can use the evapotranspiration component, you can use the rainfall pattern, you can use the temperature data set. Lots of data sets are available. You can club it together, make some sort of different types of spatial analysis, and you can correlate with each other whether how the drought patterns are correlating with which kind of the mechanism which you are observing, like that. Similarly, you will have in this data set you have multiple other types of data set. This is one type of reanalysis. You can have a terra climate data. That is another reanalysis data set which you can use it for multiple different bands where you have actual evapotranspiration, climate water deficit, you have Palmer drought severity index, you have reference evapotranspiration, you have precipitation accumulation, you have runoff, you have soil moisture, and so many other parameters which are available, and that can be used for your climate understanding of a certain regions. So, I hope that with this description you would be able to use the Google Earth Engine more efficiently. It is a kind of a cloud based program platform where you can use lots of data sets are already stored, and you have to just call that data for your specific part of area, or if you are working on the entire Indian part or something like that broader scale, you can use that say file, call that data set and start working with your spatial temporal analysis. Then you can start correlating with that data set with multiple different sets of variables, and then try to look into it which processes are actually responsible for exaggerating the climate extremes in that particular region, like that. So, thank you so much for listening this lecture.